Hello, and welcome to this Xamarin University Lightning Lecture. Today, we're going to learn about upgrading existing iOS projects to the new Xamarin.iOS Unified API. In this video, I will introduce the new Unified API for iOS. We'll take a look at what it is, why we want to migrate our existing code over to it, and we'll see a demo of migrating some existing projects. We'll then finish by talking about some of the challenges that you may face, and I'll point you to some of the resources to read more on the topic. In order to understand what the Unified API is, let's take a step back and talk about our APIs up until this point. Historically, before Xamarin was even a company, we had MonoTouch, which was the original name of the C# iOS product. MonoTouch was specifically targeted towards iOS and iOS only. Later on, a C# Mac desktop project was launched, which was named MonoMac at the time and later turned into a full product named Xamarin.Mac. As these two products evolved, one for mobile and one for the desktop, but both targeting Apple's frameworks, a lot of commonality was found. Along the way, Apple introduced 64-bit processors and corresponding APIs, first for the desktop and later for iOS. In order for Xamarin to support these 64-bit APIs, Xamarin needed to make changes to both the iOS and Mac frameworks, and took this opportunity to merge the two into one. At its core, migrating to the new Unified API involves removing the reference to MonoTouch and adding a reference to the new Xamarin.iOS assembly. As the iOS and Mac products merge, so too do their respective namespaces. Instead of having a monotouch.foundation in iOS and a monomac.foundation for the Mac, we now simply import the foundation namespace for both frameworks. All of the respective monotouch and monomac namespaces have been similarly merged as well. One of the biggest differences that you'll immediately notice when migrating your code is the changes in Apple's APIs related to data types. Both Mac and iOS APIs use an architecture-specific data type that are always 32-bit on 32-bit platforms and 64-bit on 64-bit platforms. For example, Objective-C maps the NSInteger data type to int32 on 32-bit systems and int64 on 64-bit systems. In order to match this behavior, on the Unified API, you'll replace the previous uses of int, which in .NET is defined as always being system.int32, to a new data type called system.nint, N-I-N-T. You can think of the N as meaning native, so the native integer type of the platform. And Xamarin's introducing nint, nuint for the unsigned integers, and nfloat, as well providing data types that are built on top of them where necessary. The point, size, and rectangle data types that are used with core graphics use 32 or 64 bits depending on the device they're running on. And when Xamarin originally bound the iOS and Mac APIs, we used the existing data structures that happen to match the size of the host platform, which are the data types in system.drawing. In the Unified API, these are now the appropriate Apple data types from the core graphics framework. As you can see on the slide, point F is now going to be CG point, size F is now CG size, and rectangle F is now CG rect. And there are a few different reasons that we're going to want to update our apps to use the Unified API. To start with, by combining the underlying APIs between the iOS and Mac frameworks, we're able to share much more of our UI code between the two platforms. This will allow us, for example, to start with an app targeting iPhones and iPads, and then migrate it to a Mac desktop app to be sold in the Mac App Store much more easily. Second, the Unified API provides access to the new 64-bit APIs on iOS. The iPhone 5S and above, the iPad Air and above, and the iPad Mini and above are all equipped with either an Apple A7 or Apple A8 64-bit processor. By switching our code to use the 64-bit APIs, we can achieve tangible speed benefits. According to a recent Ars Technical article, The Apple A7 chip can run 64-bit code up to 30% faster than the same 32-bit code. The A8 chip can be up to 40% faster. The third reason to switch is that, as of now, you need to support the 64-bit APIs in order to create iOS 8 extensions on iOS. And this will most likely be the case going forward as well. And lastly, the most important reason to switch to the newer APIs is that Apple is going to require it. As of February 1st, 2015, all new or updated apps submitted to the Apple App Store must include 64-bit support. If your app does not support 64-bit, you will be rejected. The time to start migrating your apps is now. With the what and the why out of the way, let's take a look at how we migrate our code. The easiest way to migrate an existing app is to use Xamarin Studio's migration wizard. The wizard is available from the project menu in Xamarin Studio. The wizard will update the project file, replace the reference to MonoTouch with a reference to Xamarin.iOS, and update as many known data type conversions as it can. There's a chance that the wizard may miss some type conversions though, and if that happens, we'll need to make the changes ourselves. If you're using Visual Studio, you can make all of these same changes manually. There's a blog post link at the end of this presentation that contains instructions on manually updating your projects. Let's now switch over to Xamarin Studio, where we'll examine 3 separate projects and migrate them each to the new Unified API. For these examples, I've created a single solution with 4 different projects in it, 3 of which will update to the Unified API. We'll start with a simple application. For this application, I have taken the iOS Stack project from the XAM 205, the Mobile Navigation Patterns class in Xamarin University. You can download this same project from the class materials if you'd like. And this project has no third-party dependencies that will interfere with our upgrade, and it's a fairly simple solution. Let's take a look at what parts of the application we can expect to be upgraded when we run through the Xamarin Studio migration wizard. First, we'll take a look at the references. Notice the reference to the MonoTouch assembly here. This is the classic API, and this will need to be replaced. Next, let's open the Menu Table View controller from the Navigation folder. And this is a simple UI Table View controller and UI Table View source. I want to point out the namespaces here. Notice that we're importing the monotouch.uikit and the monotouch.foundation namespaces. Next, we'll scroll down to the table view source and take a look at the rows in section method signature. Here, we are going to be returning an int data type, and we'll be passing in the int data type. The int data type, remember, is a 32-bit data type, and that's defined in the .NET framework. Both of these data types will need to be changed to support the Unified API. I've also added a line of code here to add a label. This line of code doesn't really do anything, but it does use a rectangle F class, and this will need to be migrated over as well. Now let's go ahead and run the migration. With our project selected as the startup and set as our current context, we'll go up to the project menu in Xamarin Studio, and we'll go down to the Migrate to Xamarin.iOS Unified API menu item. This will launch the migration wizard, and first we'll need to confirm that we want to migrate our project. When we choose to migrate, Xamarin Studio will make all the necessary changes and then reload our project. Let's look at those changes now. We'll start again with the references. Notice that the MonoTouch assembly reference is now gone, and it's been replaced with a reference to Xamarin.iOS. Next, let's go inspect that Menu Table View controller code again. If we scroll to the top, you can see that MonoTouch is no longer in the namespaces, and instead we are simply referencing the UI kit and foundation namespaces. If we go down to my sample line of code here, the rectangle F has been migrated to use the CGRect class from the core graphics framework. And finally, let's take a look at that rows and section method signature. Here, the int data type has been upgraded to the new platform-independent NINT data type, which will work on 32-bit and 64-bit, depending on the platform that it's running on. For simple apps, migrating to the new Unified API is as simple as that. Now let's go look at two more examples which have some third-party dependencies. For our second example, we'll look at a project which uses a component from the Xamarin Component Store. This project is the iOS Flyout project from the same mobile navigation patterns class that we were discussing in Demo 1. And this project is fairly simple, but it does depend on the Flyout component from the store. I've explicitly made sure that I am referencing an old version of this component. If we look at the details of the component, we can see that I'm referencing version 1.3. Now if we go to the component store and look at the history for this particular component, we can scroll down and we can read the release notes. And here we see that version 1.4 is the version that added support for Xamarin.iOS Unified. So let's go through the same migration process that we did in Demo 1, and we'll see what occurs here. So I'll set the iOS Flyout project to be my startup project. And I'll come back to the project menu and come down to migrate to Xamarin.iOS Unified API. Again, I will confirm that I actually want to migrate. And again, we can see that the namespace was updated. Our reference from MonoTouch to Xamarin.iOS was updated. But now, if we try to build this project, we'll see that we have a few different errors that we need to correct. The first is that the UI table view no longer takes a rectangle.empty. Instead, this is going to be updated to cgrect.empty. Second, we can see that we get an error here that says the type monotouch.uiKit.UIViewController is defined in assembly that's not referenced. Consider adding a reference to assembly monotouch version 0.0.0.0. And this is because the Flyout navigation controller itself is referencing monotouch. And what we need to do here is we need to update our component reference. And you can see right now that our component is red. We need to update this to the version that actually supports the Unified API. So let me go ahead and remove that Flyout component. And I'll go get more components. And just by clicking update, now we're going to have version 1.5. 1.5 does support the Unified API. If we try building this project again, correcting any rectangle F problems we might have, now our project actually builds and will run. So there we saw that when we're referencing an old component, we're hoping that the author has updated that component to support the Unified API for us. And that's not always the case, but in this case, the Flyout navigation controller has been updated, and once we correct all the errors, we can update that component, and then we can run our project just like we did before. Our third example will show the same scenario as Demo 2, but this time we're referencing some NuGet packages instead of components from the component store. This project is based on the XAM 160 Data in Mobile course in Xamarin University. In this project, I have some NuGet package references for SQLite. And we're going to be using some of the SQLite objects in the person repository class file. Once again, I'm referencing an old version of these packages before any Unified API support was added. Once again, we'll click the Project menu, and we'll choose to migrate to the Xamarin.iOS Unified API, and confirm. We can check our references and see that we've been migrated to the Xamarin.iOS assembly reference. And we'll go ahead and rebuild. The first error we encounter is the int data type here. And that's because the int data type is defined in the system namespace, and we need to include that in order to properly access that data type. Now we can go ahead and just update our NuGet packages. And then we can rebuild our project again. Our last example will show a NuGet package that has not been updated to support the Unified API. In this case, I'll be using the Akavach library, which is a library to allow us to cache remote resources in our project. Once again, we have a bit of code here to use the library, and I'm going to go ahead and migrate this project to the Unified API. This has now been upgraded, but when we try to run this project, or we try to build this project, once again we're going to get some errors. And here you can see in our error list, we cannot include both monotouch.dll and Xamarin.iOS DLL in the same Xamarin.iOS project. We can see that monotouch.dll is referenced by some of the Akavach libraries. Now, what we would normally do in this case is we would update our NuGet packages, hoping that these projects have been updated on NuGet, and we just don't have the latest yet. After those projects have been updated, let's go ahead and try rebuilding this again. And you can see we get the same errors for this Akavach library. Monotouch is referenced by Akavach. At this point, there's nothing that we can do other than contact the author of the library and ask if they're going to update it, or even better scenario would be to update it ourselves. We just saw how simple migrating our apps could be, but in that last demo, we encountered one of the challenges that you may see. The biggest challenge that we may run across is when our projects are depending on some third-party libraries. In the demo projects we just looked at, we had a Xamarin Store component and some NuGet packages. In the demo, each of these libraries had already been updated to support both Xamarin.iOS Classic API as well as the Unified API. And while Xamarin is making an effort to reach out to library authors, not every library that you may want to use has been updated though. And if this is the case, as we saw in the last demo for your project, you have three possible options. First, both NuGet and the Xamarin Component Store have ways to contact the author of our library. You can use this to request that the author updates the library to support the Unified API. Second, a large portion of the libraries in each repository are open source. You could easily fork the repository, add support for the Unified API, and contribute your changes back to the project, improving the situation for everyone. Third, you could remove the library as a dependency from your project and either replace it with something else or write your own version. We've collected some resources that will help you as you transition your projects to the new Unified API, as you see here. Explore the Xamarin documentation site for even more information as well. I hope that you have learned how easy it is to upgrade your projects for the upcoming iOS Unified API. Remember, this is something you are going to need to do before February 1st of 2015. Thank you for watching this video, and happy coding!